Good morning, Liverpool class, and welcome again. This is part 2 of multiplication. It's going to include pictures and arrays. So let's get started. So let's have a look at this picture. We have got 4 pots of crayons with 3 in each. So that would be 4 lots of 3 equals. And we can count in threes, can't we? 3, 6, 9, 12. 4 lots of 3. 4 multiplied, that's the word, 4 multiplied by 3 equals 12. 4 times 3 equals 12. I want you now to have a look at these 2 pictures. One with bags of apples in. Count how many bags, that would be a lot, and think how many apples are in each bag. See if you could fill in them boxes with lots of, multiplied by, and times. Then have a look at the dice. That one's a bit, because think how many dice there are, but we can have the 1 times table, can't we? Have a look at that. Then I want you to be able to draw a picture for each one, just like the above. Could you draw a picture for 4 lots of 5? 2 multiplied by 4. So that would be the same as 2 lots of 4. 3 times 5. 3 lots of 5. Can you think of any more? You might do 6 lots of 2. Picture for 6 lots of 2. Or maybe 4 lots of 3. Or 4 lots of 10. Have a go. Then have a look at this picture. How many lots of 2 have we got? We've got 5 pots, so that would be 5 lots of 2. 5 times 2. What is the same about them number sentences and what's different? Because 5 lots of 2 equals 10 is the same as 5 times 2 equals 10. The thing that's different is we're using the word lots of and times, aren't we? Or multiplied. Now then, I wondered if you'd be able to have a little think of this. The answer is 12. What multiplication could it be? Could it be 1? Can't be 1 in the tens because multiples of 10 end in a 0. I don't think it can be in the 5s either because 5s end in a 5 or a 0. And that digit, the 1s, is 2. I wonder if it could be 2s or 3s or 4s. You have a think. I'll give you one that I think it could be. I think it could be 3 lots of 4. 3 times 4 because I know 4, 8, 12. You ever think what others could it be? Now then, we're moving on. We call these, when they're in rows, we call them arrays, don't they? Look, there are arrays, look. So, looking at the top, how many pairs? So this, we know this at the top is called repeated addition. There's 5, add 5 equals 15. So it would be 3 times 5, wouldn't it? For that one. Oh, have I done the same? The same slide, look. Never mind. Let's have a look at this one, look. Let's write 2 additions and 2 multiplications for this array. You could write 4, add 4, add 4, and that would make 12. You could write 3 times 4, but then if you did it the other way, going down, it would be 3 and 3 and 3 and 3, and that would still make 12, and there'd be 4 times 3. It's 3 times 4, 4 times 3. We call that the inverse, don't we? It's the inverse, just like subtraction and multiplication. I wonder if you could write multiplications for this array. 2 multiplications. So look at the top, then look at it going down. See if you can have a go at that. Can you draw an array for 7 times 3? So it would be 7 lots of 3, wouldn't it? Is there more than one way? Because you could do 7 lots of 3 going down. But then if you did 3 sevens, you could do it going across, couldn't you? See if you look at this one, look, 3 8s. There's 3 8s going across, but then there's 3 8s going down. I wondered if you could have a go at doing that for 2 times 5. And then I put draw dots, arrays, to show these multiplication in 2 ways. Are you able to write the multiplication sentences for each one? Now then, to finish with, I've left us with a little problem. Can you see the multiplication 5 times 4 and 4 times 5 in this array? Maybe can you group them? That's what we have to do, isn't it? Group them. Talk that through with an adult. Okay, and I hope that you enjoy this learning. And remember, most importantly, if you can, I would love you to be able to send me some to my email, which is jtarry@newlands.wakefield.sch.uk.